So two big or a big element of any programming is being able to repeat things over and over again, desired number of times. And we have juxtaposed last time two ways to do that. One is called a for loop and the other one is called a while loop. Again, you want to program so you can repeat something 1,000 times because that's not something that you would do manually, and you actually want the computer to step in instead of you. So if we have a for loop, typically we want to repeat something for a defined number of times. Okay? And you know precisely coming in how many times you want to repeat something. And then essentially you give, so the structure is that you have for and end, and here you specify a counter that is going on for a designed number of steps. So in this particular case, if I wanted to sum up all of the elements of an array, I would define myself an array. I gotta initialize things. And then I would initialize this sum as a 0. And then I would repeat this loop for the number of elements in this array. So I would go from 1 to the length of the array. And I would basically update the sum as I go. So I would just say sum x is equal to sum x plus x of k. So I would add elements as they come along. Okay. Again, coming in, I know precisely how many times I want to repeat. Similar things to this, how many times you want to repeat, it just has to be a defined vector, a defined array ahead of time. It doesn't have to be 1, 2, 3, 4 or anything like that. It could be actually, it could have real elements. So I could have for y is equal to 0 and step by pi over 15 all the way to pi, okay? So this is any vector that I could define actually works, okay? So any vector I could define can be in there as a counter, okay? And then here in this particular loop, I'm just displaying these numbers, okay? Or sine of y. Now I can also nest loops, okay? So I can actually have another loop within the other, okay? So for every counter, so I have in this particular case an outside loop and an inside loop. So for each counter in the outside loop, I'm going to execute this entire loop, okay? So we have an example here with the arrays. You can imagine this classroom. So essentially for each counter, row counters, this is my row, I would go through all of the columns. Then I would step to another row and go through all of the columns, and another row go through all of the columns. So for each counter of the outside loop, which in this case are the rows, I would execute something for every column. And in this particular case, this was a way, so if I had a predefined A, this would be a way to define the new matrix whose elements are 2 times this old matrix plus 1. So I can do this in any type of way. And then I have a while loop, okay? In this particular loop, I would actually have not necessarily a predefined counter, but I would check whether some condition is met. Okay? So my condition might change in time, and every time I'm actually checking whether I have conditions met. It could be, for instance, so for all of the lake levels, Lake Travis and so forth, those levels are monitored by LCRA. Okay? And whether there is a drought or drought conditions, it basically depends on the level of the combined level of a number of lakes. So one could actually every morning, and there is probably a program set to do that, every morning there's like lakes level is checked, you do the sum of the levels and see whether it's below certain threshold or above for that matter, though we haven't been in this above case for a number of years now, because there has been more drought than anything, right? So then you check that level and do something, issue an alert or so forth, right? So in this particular case, you wouldn't be doing a counter or a specified counter. You would actually be checking whether something is true constantly and updating as you go. So in this particular example, you can actually keep dividing x in half, and depending, so in this particular case, you start from 1, you could start from anything, but you kind of don't know how many times you need to do this until you fall below 0.01. And that's why you want to keep dividing, and here you check with a while loop, you basically check this operation, whether it's true or not, and you stop accordingly. So the moment you keep executing and the moment this breaks down, that's when you break out of the loop. We had an example last time in class. This is dangerous in the sense that you might be in a situation that you never break the condition, so you keep going. And I was actually in that particular case that I showed, normally Control-C saves you and you should be able to get out the program with Control-C, but it actually didn't work. So sometimes these loops can run wild and take off. So I actually had to turn off, like basically exit from MATLAB in order to break the program down. So Control-C sometimes works, sometimes doesn't, but it should actually break the program. So again, for loops are for some predefined number of steps that you have to execute something, and while loops are when you are not sure how many times, but you actually have to check whether a condition is met before you stop, right? Okay, so let's do a quick example just to see whether you understand. So let's say that I give myself an A, and it's a random matrix of size 3 and 5. And I'm going to give a B, which is another random matrix of the same size. And this one I'll just scale slightly, so I'm going to say 5 times these numbers. So I created myself 2 matrices. And I know that I have actually, so if I wanted to, let's see, is Michael Wang here? So Michael, if I wanted to actually multiply, create a matrix C, such that each element of matrix C is a multiplication of the corresponding elements of A and B, what would be a one-line operation in MATLAB that I could do?
C equals A dot times B.
Okay, so C equals A dot times B. And that would basically give me another matrix of the same size. And let's check one of the elements. So this is my C of 1, 1, right? A of 1, 1 times B of 1, 1 is indeed the same number as I see here as C of 1, 1. Okay. So that was a quick check that things are working. Now, how would I actually program, and we can open a little script, how would I actually use for loops to program creation of this matrix C? So give it 2 minutes and try to write it down. So basically you can create the script So assignment is to program C such that C of ij is A of ij times B of ij with using for loops. Using for loops. Oh. Multiply script. Multiply is enough. So I save this as multiply.m. You can save it as anything. So here is a reminder of how for loops work. And I'll walk around and help, and so will TAs. If you have a two-dimensional array, it's difficult to access all of the elements in the array. Gonna add a little more comments here, so. Mm-hmm. I equals 2, and now the range of numbers. So you can actually, okay, so you want to just use size? I mean, here you know it's 3.
Size, I'll get both dimensions.
Right, so basically you could actually do this. So just extracting rows, columns, equals to size of A. So size of A, it's 2 dimensions. This way you will assign the first dimensions to rows and the second dimension to columns, if you want to.
So this is how we assign multiple
Yeah.
tables at once.
You could have just gone to 3 because you know it's 3, but if you don't want to do that, if you want to. So the question was how to extract dimensions of a matrix. Size works. So for instance, size of A is 3 and 5, but you want to grab those two numbers, so you're going to say number of rows, columns is size of A. And then rows is 3 and columns is 5. So this can help you in some general case if you want to grab what the number of rows and number of columns are.
Taking into account if they're not the same size.
But they should be here. Otherwise, we have to apply this way.
Or we take the average dimensions then? As long as we
This
get
is
the
not the regular multiplication.
dimensions.
This is way more.
Okay.
So you
So this would still work.
a special assignment was check whether these dimensions are the same, row and of A and row
And then if that
and
is
then
true,
if that's true, then right. So give yourself a check.
but if I didn't want to do that, how could I extract this data without what's done here? Because I never use them.
You can also, I think, do size.
Yeah.
Really, hold on one
I never know.
Oh, with the colon.
So let's do this. This works too. I think something like this. It would still be. I don't know that this works. No. No, not that I know. Help size. But I might not know. There's number of dimensions. But endims would be 2, right? Yeah, endims would be just 2. Maybe you could do size of, or you could just do length of A1. Length of the first column, right? Or length of the first row. That works too. There's multiple ways you can do something. There's at least 5 in every. So has everybody got a hang of the double loop? Yeah? So if you have in your board, then before this, then this is a script, right? What I wrote. Or half of what I wrote is a script. So it just has a bunch of commands put together. How would you modify that into a function? So modify the script into a function, call it multiply function or something of that sort, that would take A and B as input. So basically here I would do for I is equal to 1 through rows, for j is equal to 1 through columns, C of ij is A of ij times B of ij, and end. So this is what would create matrix C. Yes?
Can you put like in instead of 1 through rows?
Yes, and you just make sure that they're defined. But you can pick any name for it you want. Okay? So I'm normally, M and N are my common choices. But here I just decided to go for rows and columns. So what you're naming it doesn't really matter. I could have in this particular case, since I know it's 3 and 5, just put 3 and 5, but that's not good for reuse of the code, because the moment I change those numbers, then I would have to change everything. Okay. So in this way, I'm kind of creating variables that are more robust in that sense. And basically, this part is immediately transferable to be a function. Okay. Yes?
When I wrote it as a function, when I tried to run it, it said I need an input of a double. How do you get it to save as a double?
Did you give it to matrices?
I thought this was doubles.
It's undefined, so your file is not saved. It's not saved. It's not titled. So save the script or function before executing it. Okay, so the mechanics of this is relatively simple, but make sure you're comfortable with it, because this is essentially it. The rest of it, so you will write endless double for loops in this course. The rest of it is knowing what to write in here, what it is that's your assignment. So as you're programming, you will have to think through what the assignment is and how to actually compute it. But the mechanics of it, especially when I'm operating with matrices, is this. Okay? It's double for loops, knowing from where to go, okay, and how to define whatever it is that you need to define in the middle, or how to do the actual computation, which is not necessarily a programming task in itself. Okay? So you just have to know that from the problem itself. Second thing that there is, and now we will mention some good programming practices. Okay. There's an underlined C here, and you will see comment here. And comment is something along the lines that your C is growing in this loop. So initially coming in, MATLAB doesn't know how big C will be. It doesn't know what we're going to do. Okay? So you would like to know that beforehand, because if you're asking for a lot of memory, one element at a time, that can create trouble. Essentially, if you're filling up a bucket, imagine that this is filling up a bucket, but you don't know beforehand whether you need a 5-gallon or a 20-gallon bucket. So the moment you fill up 5 gallons, then you have to go and run for another 5-gallon bucket. And because that's how memory allocation goes in a computer. So every time you're beyond what it already pre-allocated something, the moment you mention C, MATLAB said, there's a matrix that's going to come, I'm going to assume it's this size, right? But then if you're asking for more than that size, then it has to go and get more memory, just like getting another bucket. So a good programming practice is to actually tell MATLAB immediately, C is zeros of that same size, rows, columns. Okay? So this is pre-allocate memory for C. This is good programming practice. Another thing that we'd like to check is, are the sizes of A and B the same before we go in? Okay? So this is now practicing if statements. So here I'm going to let you, so this is actual computation. So here, check whether sizes of A and B are the same, and compute C only if they are. So how about you all make sure that it's true? Actually, that check is best done at the very beginning. Is Mark Krugas here? Mark? No? Mitchell? Steinsberg? So how would you check whether they're the same?
If size A equals size B.
Okay. How do I write equal? Because I'm checking whether they're the same. I'm not assigning anything. And basically I'm just going to put everything else to be done if those sizes are equal. I'm going to indent the code a little for readability. Otherwise, display some error message. What's the message you'd like to and end, right? So we have if, else, end. So if sizes are equal, do the computation that is required, otherwise display an error message and don't do anything. So this is pretty much all of the good programming practices. This is also how you do things in stages. So first you actually go and do the computation, and then you add niceties to it. Checks that are good to have, but are not sort of the essence of the computation. Memory allocation is good to have, but MATLAB will execute without it. Okay. So if you're in a test situation and you don't have time, make sure you write this part, and niceties can be added later if you have time. Okay. All right. And then final thing, how do I actually convert this to, so this is just a script. The script executes. I can just say multiply. And it's going to execute, so I can clear everything. And if I execute, I will see A, B, C, I, J rows and columns show up. And I can also save this as a function. Save as multiply function. So if I'm saving it as a function, then let me get somebody to help me. Samantha? So what would I do to actually convert this to a function? What does it mean? So output and input. So I'm going to first, there's a keyword that actually defines a function, and that keyword is function, right? And my output will be matrix C, and I'm going to call this multiply function of A, B. Okay. Key thing here is that I'm not going to define matrices A and B inside this function. So I'm going to remove that. And the rest essentially stays the same. So this is now a function, and I'm going to save it, that executes for any matrices A and B that I try to give it. So I'm going to, for instance, how am I going to call this function from the command line? Mm-hmm. Oh, okay. Yeah, good point. I should ask somebody else. Let's see. Mayank? Mayank? So how am I going to execute this? I hope that's what I heard, because there's an overtone here. So basically, I'm going to pass A and B that I already have in my memory, okay? And I'm going to give a C, and now I'm going to get C as an output. Now what happens if I actually do this? Let's give a different function. I'm just going to give a mismatched sizes, okay? So I'm going to give two functions that sizes do not match. I'm going to get an error message, output argument C, and maybe others not assigned during call to multiply functions, because essentially I have this error, matrices do not match, and I'm getting out of the function without actually assigning what C is. Yes?
Could you set C to be that string of text?
Does that make sense?
Can you assign variables to be text so that C will result in something coming out?
I could give it something, I guess. I could give it a 0 too. I could give it whatever it is. It's important that I have an error message, right? So let's try. And C is now this text. That's your design, okay? but you should actually have something that flags C as a problematic. All right. So this is the essential mechanics of how you proceed in creating code. You have an assignment, you need to know how to actually compute what it is that you want to compute. Then you design in this case we had to have nested loops to access all of the elements and define all of the elements in it. And then in this iterative process, you're actually adding things to it and possibly either creating a script or a function that you can reuse later. Okay? So this is essential sort of programming procedure. All right. So one thing that you can do, if something happens during the code that you don't like or you need to break away from the loop, you can actually put a break. Okay? So you could, for instance, and this is a very simple example, but if you say for I is equal to 5, you say, well, the moment you hit 3, break. Okay? Otherwise, you print something. And you will see, so type this in to see where this break happens and what is the last element that gets printed. Typically, the moment you hit here, you will break and get out of the loop without executing anything that follows. So this should be the result of the code you type in. Now here it doesn't say why you need to break. It has to, of course, make sense in your programming assignment. Maybe you hit a 0, you don't want to divide by 0. Sometimes if you want to escape, if you don't want to use while loop, this is basically a sort of a way to force for loop to behave as a while loop. It will stop when something is encountered and get out. Some people don't like while loop because it's somewhat open-ended. This also makes sure that you don't go overboard. So while loop could go endlessly, this one will not go endlessly. Did you get a chance to type it in?
Why do we put in the loop in brackets?
Doesn't really matter. It can go without. It's essentially an array of characters. For what it,
Is that different than a string?
yeah, I don't know. I wouldn't put this. It was copied from a textbook. I actually wouldn't put it that way. So I have a question. Is Juan one here? Juan. So Juan, if I actually put this check after fprintf, what would execute here? How many printouts would I see here?
You would say 5.
No.
No.
So what would happen for 3?
Oh, you would say 3.
So I would see 3 because it would print it and then it would check and get out of the loop. So be careful with that. If I actually flip this check and this fprintf, I would actually see I is equal to 3 printed and then it would break out of the loop. So it's a minor detail, but it might be important in certain applications. Yes.
So I'm just curious, let's say that you wanted it to stop at 3, print something, and then continue, how would you do that? Would you just have to like
Then
set
you
three
would
different
you would
colors?
break. Then you would
Okay.
break. Then you would print something, not break.
Okay.
If you wanted to just do something specifically for 3, you would say if I is equal to 3, then you would do that something and continue, right? And possibly maybe you don't want anything printed, so you would have else here, right? And then end. So it's the matter of it. So this something is break in this case, which breaks out of the loop. So be careful where you place it, because you will break at that very moment. Maybe there was a little more code here and more code here. Basically, things will execute up to the break point, and then you will break and come out. Okay. All right. So we by now actually know there are certain vectorization is what we refer to MATLAB's smart way of doing things kind of in a very brief piece of code. Okay. So for instance, we know that if I had a vector of x values, okay, I could simply assign y to be sine of 3 times x. For 1, it would actually know precisely that 3 times x is a vector, where every element of this vector is multiplied by 3. And then I would do this sine element by element, right? So I would compute a sine function of every element of this array. Okay. That's called vectorization, and it is available in MATLAB. It's not necessarily available in other programming languages. Okay. So this allows for short code. It's also much more human readable code, because I'm almost writing the way I would do math. Okay. Whereas you actually, what we were going to enforce in this course is that you actually understand what's behind that. So should you need to implement this in a different programming language, you will know how. So in essence, in this particular case, you could write this code that you have this delta x that is pi over 30, and basically you know that you have number of values. If you want to discretize things between 0 and pi, this would be the number of values that you would have, so you would execute this in a for loop, right? Your x of I would be I minus 1 times the delta x, so that means that you would start with 1, you would start with 0, and you would keep adding dx. And y of I would be sine of that associated x value. So this for loop does precisely the same thing as this piece of text. This piece of code is vectorized. This is sort of the raw code where you actually do a for loop. Are there any questions about this for loop? I'm getting looks like, what? So it's a little odd way, you could say, but basically this is way to start with 0. I could have just kept adding dx to x, right? So I could have started from 0 and just keep adding a larger value. There's multiple ways to actually program this. But you can convince yourself that this formula for each I precisely evaluates this vector. So this is kind of really nice of MATLAB to provide us with these ways to define things. Okay. Also, there's one thing that goes behind the scenes that is part of the software. The way MATLAB does this is much faster than the for loop you can write, because MATLAB has optimized things behind the scenes in terms of how to access memory. Okay. So you can also do vectorization in multiple ways. So I know we already learned that if I just wanted to say, I have 2 matrices, please copy this first column of matrix A with the column B from matrix B, I would simply say, or the other way around, just say B first column is first column of A, right? So it's this simple. Whereas if you actually wanted to do things element by element, you would have to use a for loop. So for each element of this column, you would have to assign B of I1 to be A of I1. Okay. And I already mentioned that it is actually a good idea to pre-allocate memory. So just assign memory to zeros or ones or some known functions. Zeros is the easiest. Before you actually go and create an array, if you know what its size is going to be, just say, okay, in this particular case, S is zeros of the particular size you want, and then you will proceed. MATLAB will be nice enough to actually underline. So if you didn't have this line here, this S line, so if this was not in the code, then MATLAB will underline S here and say, watch out, your array is growing within the for loop that can be time consuming, or whatever is the prescripted message it says. So again, pre-allocate memory if you can. Okay. Finally, there's something we already noticed, that certain functions we can actually execute in multiple ways, and plot function was one of those. Okay? So we know that plot of xy will just plot x and y against each other. Okay? But we could have also given it the type of the marker we want, or color of the line, or so forth. Okay? And we can actually have multiple ways, so then we can also have multiple lines. So we know that this will actually create 2 lines, and so forth. So this is all the same function. This is so-called function overloading. Okay? Based on the number of input variables you put in, MATLAB will do something else. So the way that's programmed in the function, and this is definitely a useful thing to have, because it's all plot function, however many inputs you put in, you're still doing the same thing, you're plotting, right? So you don't want to have plot 1, plot 2, plot 3, plot 4, or something of that sort, so have some dummy names. Okay. So in this case, you're calling all of these functions plot, but you can execute them with variable number of input elements, so that you resolve in programming with if statements. So there's a reserved name, which is n_arg in number of arguments input. So this is short for number of arguments input, n_arg_in. Of course, there's also a variable called n_arg_out. Okay. So if number of arguments is 0, do something. If number of arguments is 1, do something else, and so forth. So this is basically the structure of the code for an overloaded function that can accept multiple number of inputs. So it can have a function that can have 0, 1, 2, and so forth. So this is something useful when you don't want to change the function name just because of the different number of arguments. All right. So basically we just have this global variables that I don't like using, so I'm not going to comment much later. And we start a new lecture next time.